Hello everyone, welcome all. Today we are going to see about the LCM and GCD of polynomials. That is GCD and LCM. What is GCD? It is the greatest common divisor, which is also called as HCF, that is highest common factor, and this is called as least common multiple. First let's see what is GCD. In the lower classes we have seen the LCM and GCD of numbers, integers, etc. Today we are going to see about LCM and GCD of polynomials. Polynomials, it would be in the type of equations. So if there are given two polynomials, that is f of x and g of x, how can we find the greatest common divisor of these two polynomials? There is a step. If you are this can be done using the long division. If you are dividing f of x by g of x like this, f of x, g of x, we get a quotient, right? This will be q of x, some value divided by r of x. This r of x is called as the remainder term. This can be written as f of x is equal to g of x into q of x plus r of x in this type of equation. Here, if the degree of r of x is greater than 0 means it should not be greater than 0, it should be less than 0. If it is equal to 0, that is r of x is equal to 0, then g of x is the GCD of these two polynomials. Otherwise, if it is not greater than equal to 0, then we come to the next step. That is, we again divide g of x with this r of x. Therefore, we get g of x into r of x in q1 of x, which is the next quotient, plus r1 of x, which is the next remainder. Here, if r1 of x is equal to 0, then r of x is called as the GCD of these two polynomials, f of x and g of x. So now let us get into the example number 3.10. What you have given is, find the GCD of the polynomials x cube plus x square minus x plus 2 and 2x cube minus 5x square plus 5x minus 3. How can we find like this? Let us take this as g of x and this as f of x. Okay, so f of x is 2 x cube minus 5 x squared plus 5x minus 3. This can be done using long division. Here x cube plus x squared minus x plus 2. Let us consider the first term itself. First term, இதோட எதை multiply பண்ணா this first term வரும் அப்படினா multiply by 2. So 2 is the quotient here. We have to multiply the 2 with this whole equation, this whole polynomial. So what we get is 2x cube plus 2x square minus 2x plus 4. நம்ம நார்மலா எல்லா எலிமினேஷன் மெத்தட்லயும் பண்ற மாதிரி இத லாஸ்ட் டேர்மோட சைன்ஸ் எல்லாத்தையும் சேஞ்ச் பண்ணும்போது this term gets cancelled. So here is minus 7x square, this one turns into plus, so plus 7x and this is minus 7. Okay, see here இதோட டிகிரி வந்து இதை விட greater than இருக்கு, இதோட டிகிரி less than இருக்கு, இதோட டிகிரி வந்து greater இருக்கு. அதனால இதை நம்ம வந்து வெளியே எடுத்துக்கணும். That is minus 7x square plus 7x minus 7. This is the remainder of this long equation, so long division. So here which is not equal to 0. This can be written as minus 7 நம்ம காமனா வெளியே எடுத்துட்டோம் அப்படினா x square minus x plus 1. We get this alone. So இப்போ என்ன பண்றோம் அப்படினா we are going to divide this polynomial x cube plus x square minus x plus 2 with this alone, x square minus x plus 1, because we are taking the coefficients minus 7 outside. Therefore, x square minus x plus 1, we are going to divide x cube plus x square minus x plus 2. See here, consider the first term itself. So, we can multiply into x to get this term. So, x, what we get is x cube minus x square plus x minus this term gets cancelled, that is 2x square. See here minus, here also minus, so minus 2x plus 2. Again consider this. See the degree of these two polynomials are the same. Again we can multiply this by plus 2, right? Plus 2. What we get is 2x square minus 2x plus 2. Again we change the symbols. plus and minus, every term with girl can get cancelled, so remainder will be 0. See here the remainder r plus r1 of x is equal to 0, hence this term x square minus x plus 1, which is the GCD of the two polynomials f of x and g of x, right? Because why we are getting this is, while dividing this polynomial x cube plus x square minus x plus 2 by x square minus x plus 1, we are getting the remainder 0. Therefore, this one x square minus x plus 1, which is called as the GCD of f of x. How can we write this as GCD of f of x comma g of x is equal to x square minus x plus 1. This is the answer of this question. So next let us move on to the next example. That is in example number 3.11, what they have given is find the GCD of again two polynomials 6x cube minus 30x square plus 60x minus 48, and the other polynomial 3x cube minus 12x square plus 21x minus 18. See, in these two polynomials we have the coefficients common. We can take from this first, we can take 6 outside, that is x cube minus 6, 5 is 30. So 5 into x square plus 10 into x minus 8. And from this second equation what we can take outside? 3. So if we take 3 outside, x cube minus 4 into x square plus 7 into x minus 6. So now we can take the coefficients outside. We just deal with these two polynomials alone, that is x cube minus 5x square plus 10x minus 8 and x cube minus 4x square plus 7x minus 6 alone. What you are going to do? Let us take this as f of x and this is g of x. We can deal this with long division. X cube minus 4x square plus 7x minus 6, and here x cube minus 5x square plus 10x minus 8. See the first term. See here also x cube and here also we have x cube. So we can multiply this polynomial with 1 alone. So when we multiply this as 1, we get x cube minus 5x square plus 10x minus 8. What we do again? We change the symbols. Yes, what we get? We get this term cancelled and this is x square alone. See, minus 10x plus 7, we get minus 3x plus 8 minus 6 is plus 2. See, consider these two terms. Here we have this degree is greater and this degree is smaller. So what we do is, see, this is not equal to 0. Again we divide this with this, that is x cube minus 5x squared plus 10x minus 8 by x square minus 3x plus 2. Consider these two equations. First term alone, when we multiply this term with x, we get the first term, that is x alone. Here x cube minus 3x square plus 2x. We change the symbols. So this term gets cancelled. This one will be minus 2x square plus, and here is minus, so plus 8x minus 8. Again we can multiply this by minus 2 to get this term, right? So minus 2. What we get is minus 2x square, minus into minus plus 6x, minus into minus, minus into plus minus, 2 2s are 4. So we change the symbols and we what get is 2x minus 4, right? 2x minus 4. Here we can take 2 outside, that is x minus 2 alone. See, the remainder is not equal to 0. This is not equal to 0. So again we have to do the long division. We have to divide this term with x minus 2 alone, right? X minus 2, x square minus 3x plus 2. Here x is there, here x square. So we multiply with x square minus 2x minus and plus, we get this term cancelled. So minus x plus 2 So again what we get is, here x minus 2 is there, here minus is, so minus 1, minus 6, minus 2. When we change the symbols, we get 0. So the remainder is 0. So what is the GCD? That is x minus 2. We have left something, right? So at the first what we took some coefficients out. From the first polynomial we took 6 and the second polynomial we took 3. So on taking GCD of these two coefficients, what we get is 3. Is the GCD of these two coefficients. Therefore 3 of x minus 2 is the GCD of the given f of x comma y g of x. Can you understand? So we have to join these two, that is 3 also, because it is a GCD of these two coefficients what we took outside. Okay, next. So we dealt with the GCD of the polynomials. The other part of the topic is, that is GCD and LCM of polynomial. What is LCM? LCM is least common factor. LCM, that is least common factor, right? So least common factor, we have already know the least common factors of integers and all. Now what about algebraic equations or algebraic functions when joined together? For example, if a cube b square and a square b cube is given, you have to find the LCM of these two terms. Here let us consider the a terms alone. Idhil evlo irukku, a cube irukku, a square irukku. Idhukku LCM edutho appadina what we get is a cube is the LCM of this a term alone. And here b square is there and here b cube is there. When we take LCM for these two terms, what we get is b cube is the LCM of b term alone. Therefore LCM of a square b cube and a cube b square is equal to a cube b cube. This is how we are going to find the LCM, right? So for example 3.12 they have given 4 subdivision. In the first subdivision, find the LCM of 8 x power 4 y square and 48 x square y power 4. So first we consider this coefficients alone, that is 8 comma 48. Normally our numbers integers ke eppadi vandu LCM edupom, like this term, right? 2 4 24, again 2 112, again 2 1 6, that is 2 into 2 into 2 into 6, what we get is 48. So LCM of 8 comma 48 is 48. Okay, then we consider these variables alone, x power 4 y square comma x square y power 4. So if, first we see the example a cube b square, like that. Okay, so what we get is, consider the x terms alone, x power 4 x square. What is the LCM of this? X power 4. And here y square y power 4. What is the LCM of this? Y power 4. Therefore LCM of 8 into x power 4 y square comma 48 into x square y power 4 is, first the coefficient term, that is 48, and then this term x power 4 into y power 4. This is the answer. Then in the second subdivision, what they have given is, they have given in the form of equation, right? Second subdivision, find the LCM of 5x minus 10 comma 5x square minus 20. First let us take this alone, 5x minus 10. How can we write this? We can take 5 common, x minus 2 alone. Then consider this 5x square minus 20. When we take 5 common, x square minus 4. We can write this as x square minus 2 square. So a square minus b square formula, what we get is a plus b into a minus b. We already know that. So x plus 2 into x minus 2. And considering this term and this term, we have 5 here, right? So 5 is the coefficient, we take 5, and x plus 2 into x minus 2. This is the LCM of these two terms. And in the third subdivision, what they have given, find the LCM of x power 4 minus 1 and x square minus 2x plus 1. Consider this term alone, x power 4 minus 1. How can we write x square the whole square minus 1 the whole square? Same in the format of a square minus b square. That is a plus b into a minus b. Therefore, a square. Here a is x square. X square plus 1 and x square minus 1. Again, this can be written as x square minus 1 square, which we can write as x plus 1 into x minus 1. Okay. Next, we consider this term x square minus 2x plus 1. So 1 then 1 1 minus 1 minus, that is x minus 1 the whole square. So இது consider பண்ணும்போது LCM என்ன வரும்? LCM is equal to x square plus 1 term gets left side. So x minus 1 the whole square is there. Here x minus 1 alone is there. So x minus 1 the whole square and one term we have left, that is x plus 1. This is the LCM of x power 4 minus 1 comma x square minus 2x plus 1. So the last subdivision of this example, fourth subdivision, what they have given is find the LCM of x cube minus 27 comma, they have given 3 terms, right? X minus 3 the whole square comma x square minus 9. Okay, first we take this alone, x cube minus 27. How can you write it as x cube minus 3 cube? We know the formula of a cube minus b cube, that is equal to a minus b into a square plus ab plus b square, right? So x minus 3 into x square plus ab is 3x plus b square is 9. And the second term, how can we write it as x minus 3 whole square? We can keep it as it is, x minus 3 the whole square. Then the third term, x square minus 9, this can be written as x square minus 3 square a square minus b square, that is equal to a plus b into a minus b. Therefore, x plus 3 into x minus 3. And we consider these three, what is the LCM of the given? It's equal to x minus 3 comes as it is x square plus 3x plus 9. See here x minus 3 is there, here also x minus 3, but here x minus 3 the whole square. So here get x minus 3 the whole square into this term, and we have left another term, that is x plus 3 into x plus 3. This is the LCM of the given 3 polynomials. Okay, hope you understand. Thank you.